Okay, now we're going to take a look at the third set. Okay, so the third set is basically concerned on the drive-through lane, which only allow 8 cars inside the drive-through lane. So you have sensor at the barrier gate, and you have also sensor at the payment gate or payment counter. Okay, so the idea is also the same. First, you lay down the input and output. So obviously you will have a start button to activate the system, stop button to start the system. You have entry sensor at the gate, and you have exit sensor at the payment counter. And then you will have a motor. Okay, so it depends on how you visualize it. Say I say that motor counterclockwise is open. And also have the output full light as well. Okay, so first you need to put all the address down. Okay, make sure you put all the address down, and then that. Okay, so the requirement is still the same. You need to make sure that if it is less than 8, the motor should be on to open. Okay, and then if it is equals to 8, the motor should be off. And then the full light also must be on. Okay, and when you start, you should initialize the register. Okay, so start drawing the ladder diagram. So it's the same thing. You put a stop button, and then to some internal register. So 0.00, 0.01, 10.00, and then I have 10.00 here, activating a differentiate bit of 40. It can be any address. I just put 40 for convenience. Okay, so you have 40 here. That is directly connected to the initialization. Okay, move 0 to D0. You can use H0, A0, whichever register that you want. Okay. Okay. Then from here, we look at the entry sensor. Okay, entry sensor should be connected to a plus increment of the register. So entry is 0.02, and then you have exit as well, 0.03. Okay, so remember we have to use differentiate bit, because if we don't use differentiate bit for entry and exit, then obviously for every scan cycle it will keep on adding. So if your scan cycle is 0.01 millisecond, then for every 0.01 millisecond, it will add 1. So you get thousands by the end of, for example, 1 second. So this we should take care of. Okay. All right. Okay. So then the next one is comparison block. So comparison can be done every scan cycle, because we want to always be able to update the flag. So we'll compare D0 with 8. Okay, so if we have less than 8, then obviously we will connect to a motor. Okay, so motor, if it is equal to 8, then we will have a full light on. Okay, I've seen a lot of people actually do the quite a difficult way, where you have the limit switch, and then the motor that lock the system. But I already put in the question that all the closing of the gate is already done separately, is already in the system, so we don't have to take care of that. Okay, so this is the idea of solving. If you do it much more detailed than this, it's fine. You still get the full marks as long as you make sure that the comparison, the flag that corresponds to the comparison is correct, is connected correctly to the output. Okay. All right.